Hello YouTubers, welcome to another video, and the buying continues. In front of you is an old multimeter. It's an Escort EDM-1111A. It's a mouthful to pronounce actually. I wish there's a easier way of pronouncing this model, such as 1111A. From my research, this was launched or appeared in a magazine, in a Australian electronic Australian magazine in 1987. I saw a cutout of an advertisement of this meter, and I'm not sure whether the color is similar or not, because the color of the advertisement itself is, I think, is in black and white, so I couldn't tell whether is this same a yellow, or whether it came out different color and then they changed it sometime later, or that kind of thing. So yeah, it's retail at the time around 98 Aussie dollars. I'm not sure how much is it in today's money. I'm sure it's a lot, but honestly speaking, in today's uh, appearance wise or design style, this obviously looks old and very 80s, quite boxy looking. That's the thing about this kind of meter. Personally, to me, I don't like this design when I was young, but when you age, you tend to look differently towards this kind of thing. They tend to look more attractive uh, later on, and then you just had to get it when the price is right. And the price was right. It's going for 10. It was going for 10 USD, so there's no excuse for me for not getting it. And it has that fluky color. Fluke is quite expensive over here. It's quite impossible to own one, even a used one. Yeah, and size wise is quite a palm full, or palm feel. When I saw the picture, this particular this the picture of this online, I thought I anticipated the size would be small due to the size of the display. I anticipate it would has less digits to display, and the size is small. But when it arrived, it's slightly bigger than the my CD771. It's quite a surprise. I think I'm getting more value in my purchase for this multimeter. Yeah, it has a tilting stand, which is quite okay. Uh, it uses 9-volt battery, and I don't quite like 9-volt battery because they're quite costly, especially when I have I think 2 or 3 test equipment that uses 9-volt battery, and I may have to resort to one battery and rotating them between those three when the need arises. Yeah, so based on the serial number, I think my guess would be either this was made in 2011 or 1996. I'm leaning toward to say was made in 1996, because I've already downloaded the an Escort catalog print scan from 2001, and from 2001. And I don't see this meter appear on that, so this must be older than 2001. And even if this came out in 2001, I doubt people would buy it, because in 2001, from the product that was displayed, Escort already moved to a curvier design, darker color, and more contrast of the silk screen to the meter itself. Yeah, it has a dedicated power button, and in case you accidentally left this on, then goodbye battery. I have to remind myself to be alert of the power button whenever not in use. This has not been used in my work yet. It's going to be a backup. So one thing is the manual ranging itself, because I'm not a manual ranging guy. I think not for a good 10 years, because since I've used this, I haven't been bothered about the ranges. I just select and let the meter does it work in displaying whatever reading that is measured. So it's something to get used to and get 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 back to. Yeah, the last time I used manual ranging is when I was learning electronic in school. So for this kind of multimeter, I have to remember, whenever dealing with voltage, whether it's a DC or AC, I have to set it on high first and gradually go to the desired ranges. Yeah. And I think I'm gonna take apart up to a point. I'm not gonna totally dismantle this multimeter. It uses self-tapping screw, which is not good actually. I prefer it to be a machine screw, but it is what it is. Very interesting. It has some shielding, so it's quite a telling sign that it's a well designed. It has more in its gut than despite the external appearance. I think it's could be meant for industry or that kind of thing. Yeah. As soon as I put the lid on this, I'm gonna proceed to measuring some things or that kind of thing. Yeah. This meter was sold just like so, without any box or manual, and the lid that came with it is actually a Sanwa lid, so I put it aside as a backup for my Sanwa multimeter. And for this, I'm gonna use my cheap test lid. Turn on the meter and let's measure something. We start with the beep first. Beep can be different from one meter to another. Quite audible and noticeable for the operator to sense a short. And we're gonna go into resistance. I have a resistor here to measure. I'm not gonna measure each of the ranges or each of the ranges. I think I'm just gonna measure one of each section, except milliamp or amp current. I don't measure that kind of thing. So what I have here is a 22K resistor. Set it to 20K. Let's see whether it's able to okay. Unable to measure. Let's go up to 200K. 21.9 21.9 21.9K. Okay, good enough, close enough and accurate enough. I'm sure there's a tolerance of 5-10% of any component. Next, we're gonna go into volts measurement. We're gonna go DC, and I have prepared my adapter, and I believe this is center negative, showing 10.17 volts. Good enough. adjust the camera. Okay. And next is AC volts. For that, I'm going to measure the mains of the our electricity. Yeah, 750. Okay. So I think we use 200 something. 237. Yeah, I think we using 240 volts here. Yeah. Next is the capacitance. Anyway, you can't measure capacitance with these two terminals. They are exclusively for volts and resistance. For capacitor, you have to utilize these two terminals over here. So I have some capacitor. I have two. I think I have prepared polypropylene. This orange one is a 15 nanofarad. So let's go to 20 nanofarad range and insert. So it's showing 12.51, good enough, I think, within the tolerance of the capacitor. And next we have a 22 nanofarad, quite popular in guitar circuit. 18, let's increase the range. 17, 18, yeah, good. Not sure whether the each of the hole here are linked. Yeah, so each of the hole here are for positive, and depending on the lead spacing of your capacitor, you may utilize whatever hole that is aligned with the component on hand. Yeah, and I have a box of a transistor here that we can measure, and to check the transistor ranges here is the HFE value. Yeah, so this is a NPN transistor. It's a 2N quadruple 2. So I'm not sure what to explain of this HFE. I think it could be useful for finding match or to match transistor for audio work or those kind of thing, or to know a gain of a transistor in order to put that into the intended use. Yeah, so I'm not sure what's the simpler way of pronouncing HFE. I guess if you are in a hurry, you might say 254 Hz. So yeah, I guess so. Yeah. So let's measure a different one, a PNP, and I'm gonna go with the S9012. Yeah. Hopefully the base collector emitter is aligned according to the what's prepared by the multimeter. So yeah, that's the reading, 334 Hz. Yeah, PNP. And with that, I think we're done with the demonstration or explanation of this Escort EDM-1111A. Yeah, 1111A seems easier to say than 11111A. Sounds like forever. Yeah, that's it for today. Thank you very much for watching, and have a nice day, and bye bye.